Look, let me start with something you've actually seen. You're standing outside on a sunny day. The sun's pretty far away, about 150 million kilometers, so its light arrives almost parallel to the ground. Your shadow stretches out on the pavement. Now watch what happens. You walk toward the sun. Your shadow gets shorter. You walk away from the sun. It gets longer. So far, nothing surprising. Shadows move when you move them. But here's the thing. Imagine something different. You're in a theater, and there's a powerful spotlight on a rotatable mount. Someone aims it at a wall far away, maybe 300 meters back. The light makes a dot on the wall. Now they rotate the spotlight slowly. What happens to that dot on the wall? It moves. But here's what's strange. The farther the wall, the faster that dot moves. Rotate the light by 1 degree, and if the wall is right there next to you, the dot barely shifts. But if the wall is far enough away, that dot can move incredibly fast. I mean really fast. Fast enough to violate relativity. But wait, relativity says nothing can go faster than light. So what's happening? This isn't a trick. This is real. And the answer tells you something fundamental about what relativity actually forbids and what it permits. Most people miss this because they confuse shadow with thing. A shadow isn't a thing. That's the whole point. It's an absence. It's what light didn't reach. And this distinction between something and nothing is the key to understanding why physics allows this at all. Let me explain how this actually works. Because the geometry is everything. Imagine you have a light source. Call it point L. And you have an obstacle blocking the light. Call it object O. And behind the obstacle, at some distance, you have a surface where the shadow falls. The light travels straight from L, hits the obstacle O, and can't get past it. But light goes around the edges of the obstacle. So on that surface, you get a region where light reaches and a region where it doesn't. That boundary between lit and dark, that's the shadow edge. Now, if the light source stays still and you move the obstacle, the shadow on the surface moves. Standard stuff. But what if the obstacle stays still and you rotate the light source? Here's the geometric reality. When you rotate a light source around a fixed point, you're rotating the rays of light. The rays are straight lines emanating from the light. If you rotate by 1 degree, the ray rotates by 1 degree. That ray hits the wall at a different spot. And as you keep rotating, the spot where the ray hits moves across the wall. The faster you rotate, the faster that spot moves. And the farther away the wall, the faster it moves for the same rotation speed. Let's put numbers on this so it's concrete. Say the light source is 10 meters from the center of rotation. The wall is 1,000 meters away. You rotate the light by 1 degree per second. How fast does the shadow move on the wall? Here's the geometry. The light ray sweeps across the wall like a broom. At a distance of 1,000 meters, 1 degree of rotation means the ray moves across about 17.5 meters of the wall per second. That's the shadow speed. If the wall were 10,000 meters away instead, the shadow would move at 175 meters per second. If it were 100,000 meters away, the shadow moves at 1,750 meters per second. And if it were far enough away, say millions of kilometers, the shadow could move at millions of meters per second, faster than light. The math is simple. Shadow speed equals distance to wall times rotation speed. That's it. Distance times angular velocity. No magic, just geometry. If you want the shadow to exceed the speed of light, 299,792,458 meters per second, you just need a wall far enough away. The farther the wall, the faster the shadow. There's no limit. You just need the distance large enough. Now, before your mind rebels, yes, I know, the speed of light is the universal speed limit. Nothing goes faster, but here's where precision matters. Special relativity forbids information-carrying signals from moving faster than light. It forbids physical objects from moving faster than light. But a shadow isn't an object. It's the absence of an object. No photon is traveling faster than light. No information is being transmitted faster than light. The light still leaves the source at 299,792,458 meters per second. It still travels outward at that speed. The rotation of the light beam is just a geometric trick. Think about what a shadow really is, operationally. You measure where light arrives, you measure where it doesn't. The edge between these regions is the shadow boundary. As the light source rotates, you're constantly remeasuring where the light is. Different photons from different moments hit the wall. You see an edge moving, but no single photon is moving faster than light. No energy is being transported faster than light. You're not violating relativity, because nothing physical is breaking the speed limit. Only the boundary between light and dark is moving fast. This matters because most people think relativity forbids motion itself, but it doesn't. It forbids something much more specific. Relativity forbids energy transfer faster than light. It forbids causality violation. It forbids you from setting up a sequence of cause and effect that breaks logical consistency. But it doesn't forbid the absence of light from moving fast. Here's another way to see it. Imagine a lighthouse beam in the fog. The lighthouse rotates once a minute. Far away, the illuminated spot in the fog sweeps across the landscape. The farther you go from the lighthouse, the faster that spot moves. At some distance, that spot can be moving faster than light, but the light itself, the photons, are traveling at light speed outward. The spot is a geometric consequence of where the light happens to be pointing at each instant. It's not a thing, it's a relationship. The moon passes in front of the sun during a solar eclipse. Its shadow races across the earth. Sometimes that shadow moves at 10,000 kilometers per hour. That's 28 times faster than a jet airplane, and it's faster than the speed of light. Nobody finds this strange because we see it happen. The shadow of the moon zips across the landscape. It's real, you can observe it. But the light from the sun is still traveling at light speed. The photons aren't breaking any law. The shadow is just the absence of those photons in a particular place at a particular moment. Relativity forbids several things very specifically. It forbids accelerating mass to light speed because you'd need infinite energy. It forbids transmitting information faster than light because that would violate causality and create logical paradoxes. It forbids any physical substance from exceeding light speed. But it doesn't forbid this. It doesn't forbid the absence of something from moving fast. The absence can be rearranged at any speed. There's nothing physical about it to accelerate. Let me give you the precise relationship. Say the light source is at distance d from the center of rotation. The wall is at distance d from the center of rotation. You rotate the light at angular velocity where, that's how fast the angle changes. The shadow speed equals d times omega. That's the formula. Distance times rotation rate. The ratio of shadow speed to light source speed is d divided by d. If the wall is 10,000 times farther than the light source, the shadow moves 10,000 times faster than the light source moves for the same rotation. You can make this ratio as large as you want, and since the light source itself is just rotating slowly, nothing about it is moving impossibly fast, the shadow speed can exceed light speed by enormous factors. A light source rotating once per hour, with a wall far enough away, produces a shadow faster than light. The physics doesn't forbid this, it permits it. Now here's what people miss. Why is this allowed? What exactly does relativity forbid, and what does it permit? Einstein's special relativity says the speed of light in a vacuum is constant and is the maximum speed at which any physical object or any signal carrying energy or information can travel. Notice those qualifiers. Physical object, signal carrying information. A shadow is neither. It carries no energy. It transmits no information. No information is being encoded in the shadow's motion that could cause an effect before light could travel to explain what the effect means. Here's the crucial distinction. If you're trying to send a message using the shadow, you can't. The shadow's motion is not causally independent. It's completely determined by the light source's rotation. You can't modulate it faster than the light source changes. You can't encode information in the shadow's speed that beats light speed because every part of the shadow's motion is a direct geometric consequence of the light's motion, and the light is constrained by relativity. Think about what information actually means in physics. It's not just any pattern. It's a pattern that carries causal influence. It's something that can affect the future. Light carries information because photons are real things that transfer energy from one place to another. A shadow doesn't carry information because it's nothing. It transfers nothing. You can't use a fast-moving shadow to send a message to someone on the far side of the wall faster than light could carry a message. The shadow's motion is already determined by events that happened at the speed of light or slower. This reveals something subtle about relativity. Relativity doesn't forbid things from appearing to move faster than light in certain contexts. It forbids things from being faster than light, from carrying energy faster than light, from communicating faster than light. The shadow of the moon during an eclipse can race across the earth at thousands of kilometers per hour. The shadow of a rotating blade can move across a surface at any speed you want. These are all well understood phenomena that follow directly from geometry and the constancy of light speed. Consider a pulsar, a rotating neutron star, emitting a beam of radiation that sweeps like a lighthouse. The beam is real. The photons are real. They travel at the speed of light. But as the pulsar spins, the edge of that beam, the boundary between light and darkness, can sweep across the sky faster than light. The beam itself doesn't move faster than light, but the edge of where the beam touches does. That edge is a shadow. It's the absence of light at that location in that moment. In quantum mechanics, physicists discovered something called phase velocity, the velocity at which wave crests move. In certain materials, phase velocity can exceed light speed. This caused confusion at first. Then people realized phase velocity and group velocity are different. Group velocity, the speed at which actual information travels in a wave, is always less than light speed. Phase velocity is just the speed at which the mathematical peaks move, and that can exceed light speed without violating relativity. Nothing physical is moving faster than light. Only the mathematical description moves fast. Shadows work the same way. The apparent motion of a shadow edge can exceed light speed, but this is pure geometry. No energy moves faster than light. No information moves faster than light. The deep principle underneath is this: relativity constrains causality. It says the future can't affect the past. It says you can't set up a sequence of events that violates cause and effect. And it does this by limiting the speed at which physical signals can travel. But shadows aren't signals. They're the absence of signals. They're not connected by causality in the way signals are. Think about what causality violation means. It means the future affects the past. It means you have a loop where A causes B, B causes C, and C causes A. That's impossible. Relativity prevents this by making it impossible for information to travel backward in time, and it does this by limiting forward time speed to light speed. But a shadow can't create a causal loop because a shadow can't carry information. A shadow can't cause anything. It can only reflect what's already caused. Here's a concrete thought experiment. You build a rotating light setup. Light source near you, wall far away. You start rotating the light. Your friend is on the wall watching the shadow. The shadow is moving faster than light from the wall's perspective. Could you use this to send a message to your friend faster than light? Could you modulate the shadow's motion to encode information that arrives before light could travel to explain it? The answer is no. Here's why. Your friend sees the shadow moving, but your friend also has to know that you're controlling a rotating light. Your friend has to understand the geometry. And any message you want to send has to be encoded in how you change the light's rotation. You can only change the rotation at speeds limited by causality. Any instruction you send to the motor has to travel at speeds limited by relativity. So even though the shadow itself moves faster than light, you can't use it to violate causality. You can't use it to send a message that arrives before the light signal explaining what the message means. This is something people don't appreciate about relativity. It's not just a bunch of rules. It's a protection against logical contradictions. It's a statement that the universe is self-consistent, and it achieves this consistency by limiting how fast cause can reach effect. Shadows are faster than light, but they're not causes. They're consequences. They're what happens when you geometrically rearrange the region where light isn't. Now, could you build a faster-than-light shadow in reality? Sure. Take a powerful spotlight, rotate it, point it at a distant surface. Done. In practice, you'd need a spotlight so powerful and rotated so precisely, and the surface so far away that we don't typically bother. But the physics works. There's nothing forbidden about it. This has been known for a very long time. Physicists have understood this since at least the early 20th century. It's not a new discovery. It's an obvious consequence of the theory once you understand what the theory actually says. But most people never encounter it because it seems counterintuitive. It seems like it should be forbidden, but physics doesn't forbid it. There's a real-world version of this that astronomers have discussed for decades. The shadow of the moon during a solar eclipse. The moon orbits Earth and blocks sunlight. As the moon moves, its shadow races across Earth's surface at speeds up to 11,000 kilometers per hour in some locations. That's faster than light speed. That shadow moves faster than any physical object could move. But nobody's disturbed because it's obviously just the geometry of the moon's motion combined with its distance from Earth. Think about what's happening during an eclipse. The moon is moving through space at about 1 kilometer per second. That's its actual speed. But the moon is about 380,000 kilometers from Earth. As the moon moves, its shadow sweeps across Earth. The geometry means that the shadow's edge on the surface moves much faster than the moon itself is moving through space. The farther the shadow is from the point directly below the moon, the faster it moves. Here's something interesting. The closer the shadow is to where Earth is directly below the moon, the slower it moves. Right where the moon is overhead, the shadow moves slowly. But just to the side as the moon moves, the shadow sweeps at enormous speeds. This is pure geometry. The moon is moving in a curved path. Points far from the center of that arc move faster. The shadow is the same principle. It's the projection of the moon's motion onto the surface, scaled by distance. This is similar to something called angular momentum. Imagine a spinning wheel. The center doesn't move fast, but the rim moves much faster. That's because the rim is farther from the center. The same principle applies to shadows. The closer you are to the axis of rotation, the slower things move. The farther away, the faster they move. For a rotating light source, this means the shadow moves faster and faster, the farther from the source you go. And here's what matters. This isn't physics being weird. This is physics being consistent. This is relativity protecting itself. By permitting shadows to be faster than light, relativity keeps the universe self-consistent. If shadows were forbidden from moving faster than light, you'd run into contradictions. You'd have situations where you couldn't make geometry work. But physics allows it because it has to. The alternative would be impossible. Let me show you why forbidding faster than light shadows would break things. Suppose relativity said shadows must always move slower than light. Then consider a rotating light source. The math says shadow speed equals distance times rotation speed. If you make the distance large enough, the shadow speed exceeds light speed. To prevent this, you'd have to limit either distance or rotation speed. But that makes no sense. There's no physical reason to forbid how far away a wall can be. There's no reason to forbid how slowly you can rotate a light. So the only way to keep physics consistent is to allow the shadow to exceed light speed. This is why relativity works. It's carefully constructed so that the things it forbids, physical propagation of energy and causality, are the only things it forbids. Everything else is permitted, and everything it permits turns out to be harmless to causality. Now here's what this means for your understanding. Light speed isn't a speed limit on motion in general. It's a speed limit on energy transfer and causal influence. It's a constraint on how the universe can affect itself. But the universe includes geometry, and space can be rearranged in ways that don't violate relativity. Light travels at 299,792,458 meters per second. That's a fundamental constant. Nothing carrying energy can go faster. But space is flexible. The distance between 2 points can change through motion or through expansion. When space changes, geometric relationships change. Shadows are made of these geometric relationships. They're made of the fact that light isn't reaching certain places. When space rearranges, shadows can rearrange faster than light. In the very early universe, right after the Big Bang, space itself expanded faster than light. This is called inflation. And inflation doesn't violate relativity because relativity doesn't forbid space from expanding fast. Relativity forbids things from moving fast through space. But space itself can move at any speed. It's the medium through which things move. Shadows are similar. They're patterns in space. They're the absence of light in particular places. An absence can be rearranged as fast as space rearranges. This brings us to something deep about reality. There's the stuff of reality, energy, matter, fields. And there's the geometry of reality. Space, time, relationships between things. Relativity constrains the stuff, but it doesn't fully constrain the geometry. Shadows are made of geometry. They're made of the relationship between a light source, an obstacle, and a surface. Rearrange that relationship fast enough, and the shadow moves faster than light. But here's the crucial point. This doesn't let you do anything forbidden. You can't use it to send messages faster than light. You can't use it to violate causality. You can't use it to change the past. The shadow is enslaved to the geometry that creates it. And that geometry is created by things moving at speeds limited by relativity. So even though the shadow itself is faster than light, it can't be weaponized for anything forbidden. Think about how a shadow is created. A light source emits photons. Those photons travel at light speed. They hit an obstacle or miss it. The pattern of where they hit and don't hit creates the shadow. If you rotate the light source, the pattern rotates. The edge of the shadow moves. But the shadow is still just a pattern of where light is and isn't. The light itself is constrained by relativity. The shadow is just a geometric consequence. And here's what's interesting. The shadow has no independent existence. You can't separate the shadow from the light source in geometry. The shadow is defined entirely by the absence of light. It's not made of anything. It's a relationship. And relationships can be rearranged faster than the things in the relationship move. Imagine a movie projector showing a series of images, one after another, very fast. To you it looks like one continuous motion. Things move across the screen, but nothing is actually moving on the screen. Different pixels light up at different times. The sense of motion is created by the sequence of images. The motion can be as fast as you want, depending on how you sequence them. Reality is similar to this. Space is divided into regions where light reaches and regions where light doesn't reach. As the light source rotates, different regions get lit and unlit. The sequence creates the sense of the shadow moving. The shadow's speed depends on how fast this sequence changes and how far away the surface is. The speed can exceed light speed because you're not moving anything physical. You're just changing which regions are lit and unlit. This is connected to something called relativistic beaming. When an object moves toward you at nearly light speed, it seems brighter because light is concentrated. When it moves away, it seems dimmer. The light is beamed, and the beaming can create effects where apparent motion exceeds light speed. Light is beamed from a moving source, so the intensity pattern sweeps across the sky faster than the source moves. And this is permitted by relativity. Astronomical jets from black holes show this effect. Material is ejected from the black hole, moving close to light speed. The jets emit light. The light is beamed in the direction of motion. The intensity pattern in the sky seems to move faster than light, but the material itself moves slower than light. Only the light moves at light speed. The apparent motion of the intensity pattern is faster than light. So the universe has many ways to create apparent faster than light motion. Shadows, beaming, geometric projections, boundary sweeping. All of these involve patterns moving faster than the things that create the patterns. All are permitted by relativity because they don't violate causality. And here's what this means for your final understanding. The universe is not forbidding faster than light motion. It's forbidding faster than light causality. It's forbidding signals that could create paradox. Shadows aren't signals, they're absences. And absence is permitted to move as fast as geometry allows. So when someone tells you nothing can go faster than light, you now know what they mean. They mean no causal signal can go faster than light. No energy transfer can go faster than light. No information that could affect the future can go faster than light. But shadows can. Patterns can. Geometric relationships can. And the universe permits this because it has to. Because the alternative would create logical contradiction. And this teaches you something profound about how to think. The universe is not made of simple rules forbidding things. The universe is made of elegant principles that permit what's harmless and forbid what's dangerous. What's dangerous is causality violation. What's harmless is geometric rearrangement. So the universe permits one and forbids the other. You now understand something that most people never understand about relativity. You understand not just what it forbids, but why it forbids it and what it permits. And that understanding changes everything. Because now, when you see something move faster than light, a shadow, a beam, a pattern, you don't think the universe is